Welcome back to Aurora Tech Channel. Today, I will review a desktop CNC from NymoLabs, the NBX-5040. It's slightly smaller than the flagship model, which is a 6040 machine. As the name suggests, the working area is 500 by 400 with a maximum Z travel of 95 millimeters. This machine cost $1,400, which is $400 cheaper than the 6040. The motion system on the X-axis uses 15mm linear rails and 1605 ball screws. The dual Y-axis uses dual 20mm linear rods and 1605 ball screws. The Z-axis uses dual 15mm linear rails and 1204 ball screws. The bed is an aluminum and MDF hybrid bed, and for the spindle, instead of a small spindle commonly seen on other machines, it comes with a custom 710-watt router. It has similar power to a Makita router that I used on other CNC machines, and it also comes with an ER11 chuck that allows you to use all ER11 collets and common CNC bits. The power is connected to the controller box, so the spindle power can be controlled using G-code, but for the speed, you still need to use the knob to manually adjust. The stepper motors are high-torque NEMA 23. The machine runs Gerbil firmware, and the motherboard and stepper drivers are packed inside the electronic enclosure with integrated cable management. There's a 2.8-inch touchscreen for you to work completely offline. Just generate G-code from your computer, and it can run without you having to connect the USB cable to the computer and running another G-code sender software. For other accessories, it comes with some basic bits, a Z-probe for tool height setting, limit switches on all axes, and 4 spring-loaded clamps for fixing the workpiece. As NymoLabs just launched some new accessories, I will also test out the MPG handwheel laser module and the 4th axis in this video. I want to thank NymoLabs for sending us this machine to review and for sponsoring today's video. And with that, let's get started. The machine came in a large box and it weighs 45 kilograms or 100 pounds. All parts are protected with thick laser cut foam, and the machine's structure is pretty simple. We have the dual Y-axis, the gantry that includes the X and Z axis, the 710-watt router, the controller box, the front frame of the machine, the T-slot MDF hybrid bed, some tools, cables, and the user manual. Putting this machine together is really easy if you have the strength. We will start with putting together the frame and installing the hybrid bed. Put the gantry on top of the Y-axis. Install the router, connect some cables to the controller box, and we are done. Let's turn it on, do homing, and all axes and limit switches are working normally. The router is also working, so we can start our first job. I will start with this piece of 1/4-inch walnut solid wood. The machine came with 4 spring-loaded clamps, and I will just put a 2mm MDF underneath to protect the hybrid table. I will go to Fusion 360 to generate the toolpath for this Gryffindor logo, starting with engraving with a 15-degree engraving bit, then switching to a flat end mill to run a contour operation to cut out the logo. I will use the bits that came with the machine, starting with the engraving bit. Let's set the tool height with the probe. Then we can start the job. I will just engrave a 0.5mm depth to test the machine and make sure everything is working. Okay, it seems everything is working fine, but as expected, the 0.5mm depth is too shallow. So I will redo the same engraving operation, but with a 1.5mm depth. The screen is providing real-time position of all axes as well as the feed rate, but the spindle speed has to be adjusted manually using the knob of the router. Okay, the 1.5mm depth looks much nicer. I will then change to a 1/4 inch 2-flute flat end mill and set the tool height using the probe. Then, I will run the contour operation to cut out the logo. The engraving can look a bit better if I run a cleanup pass, but overall it still looks alright. The cut is nice, all edges are very clean, and I don't need to sand it or do any post-processing. Next, I will try to work with acrylic. I will engrave a logo using the same engraving bit and cut the logo out using a contour operation. I will still engrave 0.5mm depth on this acrylic. For acrylic engraving, we will need another cleanup pass. As you can see, the first pass is not very clean. So I will run the exact same code again. Okay, after the cleanup pass, it looks much better and we can now run a contour to cut it out. I think the result looks pretty good. The engraving is presentable after the cleanup pass and the cut is clean. I will cut another ninja star on the same piece of acrylic, starting with the hole in the center. Then I will run another contour operation to cut it out. I actually expected it to fly away as I didn't use tabs, but it was just stuck in the clamp. The result is beautiful. The edges are clean and the corners are actually quite sharp. Then I will try to cut some metals. I will make a few slots on this 6061 1/8 inch aluminum plate. I will start with the 0.25mm step down and all the way to 1mm. The first 4 slots will be cutting at 500mm per minute with the ramp and plunge feed rate at 166mm per minute. Then, I will double the speed at 1000 millimeters per minute for cutting and 333 millimeters per minute for ramp, and plunge to cut 2 more slots with 0.25 millimeters and a 0.5 millimeter step down. On the screen, it looks a bit blurry, but the metal is fine. Just the sticker at the back makes it look bad. I will remove the sticker and take another picture, and it looks much better. The 0.25mm step down is smooth, and even when milling at double speed, it still looks fine. The 1mm step down is still alright. For a rough operation, I think it's totally acceptable, but for finishing, I would stick with the 0.25mm step down. Let's run the exact same code on a brass plate. As the brass plate is a little smaller, I will manually stop the last slot before it mills into my mini vise. Let's put the brass and aluminum plates side by side for comparison. I think the result on brass looks a bit cleaner, even though brass is slightly harder than aluminum. But the results of both metals are good, as I can put them all the way to a 1mm step down without issues. There is an optional laser module available for this machine, and it's a very basic 10-watt module. As this machine can't fit inside my laser enclosure, I will use a smoke purifier for smoke management. As this 10-watt module is not that powerful, I will just test it with 3mm plywood. The laser module has an air assist nozzle, but it didn't come with any air pump, so I will just test what I received and do the cutting without using air assist. The result is not too bad. Of course, the cutting will be cleaner with an air pump. I will also engrave a photo on this plywood. As a CNC machine uses ball screws instead of belts to move the axis, the speed is limited to around 4,800 millimeters per minute, so it actually took 40 minutes to finish this photo. Here are the results. As this is just a very basic 10-watt laser module, it won't engrave quickly or be able to cut thick materials, but it allows you to attach it to the machine and do some light engraving without needing the space for another laser engraver. I will talk more about this later. As NymoLabs has also released a new 4th axis rotary roller, I will be testing that out as well. If you've watched my laser engraver reviews, you'll know that I engrave on oak wood cylinder in almost every video. I've saved quite a few of them, so I might be able to reuse them on this machine. I'm going to make a chess piece. It's an old design from when I first started learning 3D modeling with Tinkercad. I'll just import the STL into Fusion 360. I'll create the stock as a fixed size cylinder and position the queen at the center. My first operation will be roughing, and I'll use the same 2-flute end mill I used earlier for the job. It'll shave the cylinder to remove as much material as possible, leaving only 0.5mm for the second operation. Then, I'll use a 1mm ball end mill for finishing. Since this is my first time generating a 4-axis toolpath from Fusion 360, I made some mistakes, so I made some adjustments and tried again and again. The cylinder is still usable. I'll just reattach it and start again. This time I figured out the errors and it seems to work as expected. When I reattached the cylinder, it tilted a little, but since the chess piece is smaller than the cylinder, if it's not tilted too much, the impact is minimal, and I'll just let it finish. It finishes in around 2 hours and 15 minutes. The roughing operation is really rough. It looks like corn you took bites out of. However, our second operation, using a 1mm ball end mill for finishing, should be able to polish it smooth. It seems like the 1mm ball end mill is doing a really good job. The surface looks even better than I expected. However, when it's almost finished, the tilted cylinder does show some impact here. As the base of the chess piece is larger, there isn't enough tolerance unless the diameter of the cylinder stock is even larger. So we'll just stop the machine and manually use the MPG hand wheel, using it like a mini lathe to finish the bottom manually. It's not as smooth as those made by a program, but who knows if this isn't part of the design. I'll just cut the bottom using the miter saw. The result is still awesome, and the surface is beautiful. I 3D printed the same STL with some wood-filled PLA and put them side by side. The one made of real oak wood looks 100 times better. This is a chess piece I would pay for. Okay, let's talk about the pros and cons of this machine. As the machine is very similar to the 6040 model, it actually shares many of the pros as well as the cons, but let's start with the pros. 1. This machine is heavy and weighs 100 pounds. It's not as heavy as the 6040, which was 130 pounds, but it's still heavy and rigid. The X, Y, and Z axes are all using ball screws. The X and Z axis use 15mm linear rails, while the Y axis uses 20mm linear rods instead of linear rails like on the 6040 machine. But it can still cut metal at a pretty aggressive speed with a maximum 1mm step down. 2. The custom router is the exact same as the one on the 6040. The advantages over adding a Makita or similar wood router to a regular CNC is you don't have to spend another $130 for the wood router and $30 for the mount. This custom router's power is connected to the machine, so it can start with the G-code, while an added-on Makita router needs to connect to another power source and has you manually turn it on and off. And the setup is not only handy, it's also safer, as when you hit the emergency stop button, the machine and the router all stop together. It uses an ER11 chuck, so you can put different collets and use a broad range of router bits and end mills. 3. The touchscreen is convenient. I conducted all CNC tests using it without connecting the machine to the computer, except for the laser module, which I use with Lightburn. You can simply export files from Fusion 360 and start them using the touchscreen, eliminating the need to put the machine next to your computer. The touchscreen also lets you change the settings, save it to the firmware, and use the Z probe to set tool height, and overall, it can replace the need for PC software entirely. When I reviewed their 6040 machine previously, I noticed some minor typos on the touchscreen, but NymoLabs promptly addressed this issue by releasing a new firmware. 4. The assembly of the machine is pretty straightforward. As long as you have the strength, it won't be a problem to put everything together in about 30 minutes. For us, it took a bit longer, as these parts are pretty heavy. 5. Most of the small details are well designed. The hybrid aluminum and MDF bed provide a sturdy surface, and they're complemented by a set of high-quality spring-loaded clamps to secure workpieces. The pre-installed cable chain is also a good addition, with all cables from the axes, including stepper motors and limit switches, integrated into 2 multi-pin cables. This configuration ensures a cleaner connection and reduces the likelihood of errors during setup. 6. Most of the new accessories are well made and high quality. The 4-axis clamp force is strong and the body is heavy and it works very well. The MPG wheel is also well made and the control and feel are really good. Even though the oak wood cylinder was misaligned after 2 crashes due to my own errors, I could still use the MPG wheel to manually control the 4-axis and recover the workpiece. This would have been much more challenging if using only the touchscreen or computer software. The MPG wheel enables users to operate the machine like a manual milling machine or lathe, which is particularly helpful when performing simple cuts without the need for complex software like Fusion 360 to generate tool paths. Now for the cons. 1. The 2.8-inch touchscreen is too small. It works, but it falls short compared to the 4.3-inch touchscreen found on even a $200 budget 3D printer. So considering the price of this machine, it would be more appropriate to give it a larger touchscreen. Additionally, the limit switches are very basic, like those found on budget 3D printers. I think this machine deserves better quality limit switches, which only cost a few dollars more. 2. Since this machine can operate in 3 different modes, switching between laser engraver and CNC requires the manual adjustment of parameters like feed rate, acceleration, and enabling the laser module. These can be done either using the screen to enter the numbers or via the computer software. Also, when connecting the 4th axis, certain parameters need to be verified. To streamline this process, it would be better to add a mode menu on the screen, allowing the user to choose between 3-axis CNC, 4-axis CNC, and laser engraver modes. Adding an icon or text showing the current mode of the machine would also make things more clear. 3. The laser module is a very basic 10-watt one, but the biggest limitation of this setup is actually not the power, it's the speed, as the speed of the ball screw-driven CNC motion system couldn't match the speed of a belt-driven motion system on a laser engraver. But it could still perform similar to a 10-watt laser engraver at a slower speed at around 5,000 millimeters per minute or slower. And the smoke management is also something you need to consider, as the CNC machine is larger than any regular laser enclosure in the market. 4. Compared to the flagship 6040 model, the y-axis of this 5040 is changed from linear rails to linear rods, as the rods are not protected as well as the 6040 machine. When you use a vacuum to clean up the bed after a job, you need to clean the y-axis as well. The z-axis of both machines are unprotected, so it would be better to add a bellow cover. Another new accessory from NymoLabs is this dust shoe. We didn't end up testing it in the video, as when we installed it, it made it really hard to film how the part was being made. But if you do use a dust shoe, it definitely helps to protect your linear rods and linear rails from debris and dust. In conclusion, the NBX-5040 CNC from NymoLabs is well made, while this smaller version comes at a slightly more affordable price compared to the flagship 6040 model. It also offers a smaller working area and removed one linear rail from the X-axis, replacing it with linear rods on the Y-axis. I haven't noticed any obvious performance issues that come from these changes, and I can still use it to cut metal as aggressively as the 6040. However, the Y-axis may require regular cleaning. When I reviewed the 6040 machine last year, I planned to include it on my recommendation list. However, at that time, there were limited accessories available, and the screen UI still had some minor issues, so I ultimately didn't include it. Now, with the screen UI bugs resolved and new accessories launched, I'm confident to include one of their machines on my CNC recommendation list, making it the second CNC machine on the list. While it may not have the same level of advancement or innovation as the $6,000 Carvera auto tool changer machine, it does offer advantages over other machines in the market. Taking into account factors like price, features, and performance, I'm awarding the title of the best performing mid-size desktop CNC to the flagship 6040 model, which comes with all linear rails, as in terms of performance, the 6040 still performs slightly better. If you were interested in the NymoLabs CNC machines, I've included the link to them in the description and the link to my website, auroratechchannel.com. In addition to the recommendation list, my website also monitors prices for over 100 popular 3D printers, laser engravers, and CNC machines, and provides detailed specs for easy comparison. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.